This is Dr. John Bergduff. This video is a follow-up to a couple of other videos I've created that talk about converting units of measure. I have one that talks about the English system and then converting back and forth between the English and metric systems, and another one devoted strictly to the metric system. In this video, we're going to apply the techniques that I covered in those videos to units that are a little bit more involved, particularly units of measure that involve area or volume, and also to what I'm going to call compound units that mix together more than one type of unit. For example, miles per gallon. So let's jump right in, and I want to start by doing an example that really is a review of what's in the other videos in case you haven't seen that, just so I can show you the approach I take in converting units. So this example says, if a person weighs 150 pounds, what is his or her weight in kilograms? Now, to do any unit conversion, you have to find some sort of table of values that convert from one system to another. And the sad thing is that you may not have a formula that would directly, for example, convert you over from pounds to kilograms. I have a table, for example, that tells me that 1 pound, LB is the abbreviation for pound, is equal to 453.59 grams, which doesn't get me to kilograms, it only gets me to grams. But I do know that the prefix kilo in the metric system stands for 1,000, so I also know that 1 kilogram is 1,000 grams. Those two formulas essentially allow me to build a chain from the unit that I have to the unit I want. I may not be able to convert pounds to kilograms directly, but I can convert pounds to grams, and then I could convert grams to kilograms. And I'm just going to emphasize that this particular formula will help me get through this link of the chain, and this formula will get me through this link of the chain. Now, what I'm about to do builds on the fact that if you take any quantity and divide it by itself, so you create a fraction with the numerator and the denominator the same, that such a fraction is equal to 1. And if you multiply any quantity by 1, it doesn't change. Since 1 pound is equal to 453.59 grams, if I made a fraction that would put 1 pound in the numerator and 453.59 grams in the denominator, I would in fact be creating a fraction that is equal to 1 because I'm dividing by the same thing. In fact, any conversion formula can be converted into two fractions, both of which are equal to 1. I, in this fraction, put pounds over grams, but I also could have put grams over pounds. So another fraction that's equal to 1 would be 453.59 grams divided by 1 pound. If I start with my 150 pounds and I multiply that by 1, I'm not changing anything. Well, I have two fractions here that are both equal to 1, so I could multiply 150 pounds by one of these two fractions, either one, and I would not be changing the value. If I choose the fraction strategically, I might be able to divide out the units that I'm starting with but no longer want and replace them with units that I'd rather have. What do I mean by that? Well, look at the second fraction and let me multiply the 150 pounds by 453.59 grams divided by 1 pound. Again, that's multiplying by 1, so I'm not changing the value. However, especially if I realize that the 150 pounds that I'm beginning with can be thought of as over 1, I realized that the units of pounds divide out. Much like you would divide out a common factor of whole numbers, or even variables like an x in the numerator and an x in the denominator, the pounds divide out. And the net result of that is, once I do the calculation, I will have an answer now that is in grams. Multiplying by that fraction essentially takes me down the first link of the chain. Now, if I just can go down the second link, realizing that I ultimately want my answer to be in kilograms, I can create a fraction from this formula, from this conversion factor, I should say, that would make the old units, which are now grams, and replace them with kilograms. And I think you can see that I can do that if I multiply by 1 kilogram over 1,000 grams. And see here that the grams would now divide out. And simply, if I do this calculation, I will get an answer in kilograms. Now, the calculation you would probably want to do on a calculator, anything that's in a numerator is being multiplied, anything that's in the denominator is being divided. So what you would actually punch into your calculator is 150 times 453.59 divided by 1,000. And I'm going to pause briefly for you to do that. And hopefully now you have done that calculation. And I'm going to write an answer rounded off to 2 decimal places. I got 68.04 kilograms. 150 pounds is the same as 68.04 kilograms. So I hope that's helpful. Now, but let's build on what I really wanted to talk about today. I wanted to talk about units of area and volume and how those work. So, how many square inches are in 6 square feet? Now, I do know that there's a connection between feet and inches. This one, fortunately, is well known. We know that 1 foot is equal to 12 inches. We are starting with an area of 6 square feet, and I'm headed towards inches, so I believe I have a very, very short chain that goes directly from feet to inches. But here's an interesting thing. I create the fractions that move me down the links of my chain by taking conversion formulas like this one and putting the numerator over the deciding who's going to be the numerator and who's going to be the denominator. If I put 12 inches over 1 foot, that would be multiplying by 1, and it would have the effect, like in the previous example, of dividing out an old unit and replacing it with a new one. However, I don't just have feet this time, I have square feet. So how do I deal with that? Well, it's actually pretty simple. What you do is you multiply by the same fraction a second time. Because now you have feet times feet in the denominator, and the feet times feet in the denominator will divide out the feet squared in the numerator, and leave you with a fairly simple calculation that's not too hard to do. 6 feet squared, converted to inches squared, you would take 6 times 12 times 12. The answer would be in inches squared, and the numerical value is 864 inches squared. That's how you convert from square inches to square feet. So if we have squared units, we simply have to multiply by conversion fractions twice. And not surprisingly, if you had cubic units like volume, you would have to multiply 3 times. This problem has another little twist to it. In the metric system, volume can be expressed in 2 ways, either in terms of liters or in terms of cubic length units. There's a connection between the liter world and the cubic meter world in this identity right here. 1 milliliter is equal to 1 cubic centimeter. If you're familiar with medicine, cubic centimeter is also often written as cc, and so you'll hear a doctor or a nurse say that 1 cc is the same as 1 milliliter. That's really the same formula. How many liters are contained in a box holding cubic meters? So what I'm going to have to do is somehow build a chain that would get me from cubic meters to liters. And what I have circled in the gold there will help me get there, but I'm going to need several steps. And don't worry that I'm not talking about cubic meters. I'm just going to talk about the single unit of meters, and we'll deal with the exponent later. I can follow a chain, though, that would take me from meters to centimeters. I know what that formula is. There's a formula that connects centimeters to milliliters. Now, no, it's not a direct comparison from centimeters to milliliters, but it creates a connection. And then finally, there's a chain I could follow from milliliters to liters, which is the unit I ultimately want. So based on things we know about the metric system, we know that a 1 meter is equal to 100 centimeters. We know from the conversion formula circled in gold that 1 cubic centimeter is equal to 1 milliliter. And we also know from the metric world that 1 liter is 1,000 milliliters. So let's look at how we would build the fractions to move us down the lengths of this chain. We're starting with 7 cubic meters, or meters cubed. I'd like to multiply by a fraction that's equal to 1. That would move me down the chain. Building on the last example we saw, that can be done by simply multiplying by a given conversion factor more than one time. I can multiply by 100 centimeters over 1 meter, and that would cause one of the factors of meter to divide out. Because I have meters cubed, I would simply have to multiply this 3 times. And we'll do the math all at once. The calculations, I mean. But notice how we have everything we want right here. We have meters times meters times meters dividing out cubic meters and giving me an answer in centimeters cubed. That gets me down the first link of my chain. The second link is easier because if you look at what we have, we've got cubic centimeters, centimeters times centimeters times centimeters. To get down the next link of the chain, I'd need to make a fraction out of this fact, getting old units to divide out and new units to take their place. That can be achieved by multiplying by 1 milliliter over 1 cubic centimeter, so that the cubic centimeters here divides out with centimeters times centimeters times centimeters here. Now we have followed the next link of the chain, and we have converted our value to milliliters. We finally want to convert to liters, and we have one more fact that we can use. Make a fraction out of that so that the old unit of milliliters divides out and the new unit of liters comes in. And that would be achieved by multiplying by 1 liter over 1,000 milliliters, so that my milliliters cancel out, divide out, and give me an answer, which is what I want, in liters. Now, the mathematical calculation that I want to do, if you notice all the units are gone except the liters, is that I want to take 7 multiplied by 100, multiplied by 100, multiplied by 100, divided by 1,000. It is so easy to multiply by powers of 10 because you really just move the decimal place. If you multiply by a power of 10, you move to the right. 100 would move you 2 places to the right. Another 100 would move you 2 places to the right. Another 100 would move you 2 more places to the right, for a total of 6 places to the right. But dividing moves the decimal place back to the left, and dividing by 1,000 would mean you'd move the decimal place 3 places back to the left. The net result of that is really you've moved the decimal place 3 places to the right. So that would be 7, 1 place, 2 place, 3 places, and the unit was already determined, 7,000 liters. So that one's pretty involved, but I hope that made sense. Finally, I want to talk about what I meant by a compound unit. Compound unit is simply a unit that involves more than one measurement at the same time. In this case, we're going to be dealing with the unit of miles, which has to do with distance, and the unit of hour, which has to do with time. Miles per hour can be written with the unit as a fraction this way. Miles per hour is miles divided by hours. And what I need to do is I need to convert miles to feet and hours to seconds. So I'm going to build a chain that would essentially get me both of the units changed. Or maybe it might be a little bit simpler to think of it as 2 chains so that we don't get too confused. We do know that there's a nice connection that would take us from miles directly to feet. And I'm looking this up hypothetically in a book or something like that and getting a conversion formula. But the fact is that 1 mile is 5,280 feet. I looked that up, or maybe I already know that. That converts my unit of distance. My unit of time will take a little bit more work. I'm given hours and I want seconds. I may have to go through an intermediate step on that. I might have to say, go from hours to minutes, and then minutes to seconds, because I know that 1 hour is 60 minutes, and 1 minute is 60 seconds. Let's use these conversion facts to see if we can move down sort of this double chain to get my units converted to feet per second. So let's start with the 60 miles per hour, and let's deal with the units of length first of all, the miles. My first conversion fact over here connects miles to feet. If I want the miles to divide out, I would want to write 5,280 feet divided by 1 mile, so that miles divide miles and converts miles to feet. That essentially takes care of that first chain. I don't have to create a separate fraction or anything. I can work right here. I'm going to continue to go and deal with the units of time. Now, this is interesting. This time the unit of time is in the denominator. You can see it right here. So if I want the unit of hours to divide out, the fraction that I choose to multiply by would need to have hours in the numerator, not in the denominator. So I could write 1 hour divided by 60 minutes, and the unit of hours here divides the unit of hours there. And going one more step down the chain, that got me this far. I also know that 1 minute is 60 seconds. Tell me, I'm going to give you half a second to think this over. Should I multiply by 1 minute divided by 60 seconds? Or should I multiply by 60 seconds over 1 minute? The answer is you want to multiply by 1 minute over 60 seconds so that the old unit of minutes will divide out. And if you look carefully through all that scratch out, you'll notice that your final answer, once you do the calculation, will be in feet per second, and that's exactly what we want. The calculations are done perhaps by calculator. You might notice immediately that the 60s divide out. This 60 right here can divide this 60 right here, so that your only calculation is 5,280 divided by 60. That number should give you 88, and the unit would be in feet per second. So I hope that's been a helpful video that helps you understand converting units a little bit better, and best of luck.